right, we are looking at 6-7 and 6-8 exponential logarithmic models and regression. So first thing I want you to do is grab your graphing calculator, if you would please. And I want to make sure that we are in the right modes. So if you'll hit your mode button, and again, remember when I hit something, it lights up in red. When you hit your mode button, I want you to come over here and check and make sure down here at the very bottom, your stat diagnostic is on and your stat wizard is on. So if, for instance, my stat diagnostic was off, it would be highlighted. So I'm just going to arrow over to on and hit enter, and you'll notice that now on is highlighted. So that means that my stat wizard is on. All right, so we are looking at exponential regression to start with. Remember that an exponential function is in the form y equals a times b to the x, and when b is a number larger than 1, we have exponential growth. If it's a number between 0 and 1, we have exponential decay. So the way that we're going to do this, I'm going to just kind of walk you through the steps, and then we'll do one together actually on the calculator. So if you want to do an exponential regression, now we've done linear regressions before, and an exponential regression is going to be just like that, and a logarithmic regression is going to be just like that. So first, we're going to go to statistics and go to edit to put in our list. Now, it's a really good practice to clear out any data that's in your list before you start putting new things in. And so the way that we do that is we scroll up and we sit on top of list 1 and we hit clear enter, and it will clear that whole list at one time instead of us having to clear it number by number. You do not want to hit delete. If you hit delete, it literally will delete the list, but it's not a problem. All you have to do is just come back to setup editor and it will restore those lists for you. So it's not a problem. So we've gone up to L1 and hit clear enter, gone up to L2 and hit clear enter. And so now our lists are clear and we can put in whatever the data is for the problem that they've given us. All right, so in list 1, we're putting our input, our independent, our x values. In list 2, we're putting our dependent, our output, our y values. So then we want to graph a scatter plot. Now, scatter plot is exactly what it sounds like. It's just you plot the points and they're scattered all over the graph. So we want to graph a scatter plot and determine what type of pattern is this. Is it linear, exponential, logarithmic? Like, what is it? So the way that I do that is now that we've got this data in statistics, I want to go plot those statistics. So I'm going to go to second y equals to get to my stat plot, pick that very first one and turn it on. And from the different types of graphs there, we're going to select scatter plot. We're going to tell it we put our x values in list 1 and our y values in list 2. And you can mark it by anything that you want with any color that you want. All right, so once you have that information in there, you could set your window by hand, but what's a whole lot easier is to get your calculator to set the window for you. So if you will hit your zoom button, and then zoom number 9 is zoom stat, and that will set the window for you so that you have your scatter plot. So now I can look at that and I can verify that's an exponential pattern, and that lets me know I want to do an exponential regression. Okay, so to do the exponential regression, I'm going to go back to statistics, the same place that I was up here when I put my information in my list. I'm going to go to statistics, but instead of going to edit, I'm going to go over to calculate. And here's where that linear regression was that we worked with before. If it looked like a parabola, we do a quadratic. We've got cubic, quartic, logarithmic, and then here's our exponential. So since we know this has the exponential shape, we're going to choose exponential regression. All right, so this is probably set already in this way by default, but our x list would be list 1, our y list would be list 2. We're going to leave our frequency blank. And then when it calculates my equation, I want it to go ahead and put it in y equals for me so I don't have to type it in. And so right here where it says store regression equation, I want to tell it to store it in y1. And so I'm going to do alpha trace. So the alpha button and then the trace button. and that will pull up this menu that I can just pick that very first one, Y1, and so you can see that shows up there. Okay, then come down here and get calculate, and when I do, my calculator will create an equation to fit all those points. So here's what my calculator gave me. So notice that it's telling me this is what I'm going to put in for A, and this is what I'm going to put in for B. So that would just be 4.185403888 times 1.30221977 to the x. Now, usually they'll tell me to round off to like 3 or 4 decimal places or something. This number right here, this R right here, that's showing me my correlation. My correlation is just my relationship between these two things. The closer that number is to 1 or -1, the stronger the correlation is. So if it is a positive value, then it should be closer to 1. If it's a negative value, it should be close to -1 for it to be a strong correlation. All right, so then if I hit my graph button, because I told my calculator to go ahead and put my equation in Y1 right here, if I were to hit Y equals, this equation would automatically be typed into Y equals for me. So when I hit graph, it's graphing it for me. And so you can see, man, that equation that the calculator created, that is a fantastic fit for that graph. All right, so now let's do one together now that you've kind of got the steps that we're going to follow. All right, so to begin with, let's grab our calculator again. All right, so I'm going to go to statistics and I'm going to go to edit. All right, and if I wanted to clear out a list, remember that it's a good idea to get in the practice of clearing them. So I just go sit on top of it and I hit clear enter and it clears that whole list at one time. So again, sit on top of it and hit clear enter and it clears that whole list. So I went ahead and preloaded list 1 and list 2, so I didn't want to clear those, but this is the data that they gave us for our problem. So in 2007, a university study was published investigating the crash risk of alcohol impaired driving. Data from the crashes was used to measure the association of a person's blood alcohol level, BAC, with the risk of being in an accident, and the table shows this information. So does the blood alcohol content determine the risk of crashing? Or does the risk of crashing determine the blood alcohol content? Well, the blood alcohol content is what determines your risk of crashing. So we're going to put the blood alcohol content in list 1 as our independent input. And then we're going to put our relative risk of crashing in our list 2, our dependent, our output. And there are a few more values down here. So if you're looking at mine, be sure that you notice there is an extra value off of our table there. Okay, so once we have all of those values in there, then I'm just going to quit to get out of there, kind of go back to a main screen. So now I want to plot those so that I can see, are they linear, exponential, logarithmic, like what are they? So again, remember we've got our statistics in there. The way that we plot those statistics is second y equals to get to our stat plot. I'm going to select that first plot and turn it on. And then I can come down here and choose what graph I want. I want a scatter plot. I just put my data in list 1 and list 2, so that's what I want it to use. And then whatever mark you want and whatever color you want. Now, I can set the window by hand, but remember it's a whole lot faster to let my calculator do that for me. So I'm going to go to Zoom, and then I'm going to choose number 9, the Zoom stat. You can just type the number 9. All right, and when I do, then it sets the window for me, and it's easy for me to see that this is exponential growth. This is an increasing exponential function. So that means that I do want to do an exponential regression. So I'm going to go back to statistics. I'm going to go over to calculate, and I'm going to go down until I see exponential regression. All right, so when I do, this should be list 1 and list 2 by default, but if for some reason it wasn't, see how L1 is right here in blue? I would just hit second L1 and then come down here and hit second L2. I'm going to leave my frequency blank, and then I want to, once it creates the equation, I want it to put it in Y1 for me. So again, the way that I get that is alpha and then trace, and then that very first option there, you can see 1 is already highlighted, so you could pick the number 1 or just hit enter, and it'll put your Y1 there, and then come down and calculate. So when I do, it creates the equation for me. So you can see we're going to put this in for A, we're going to put this in for B, and then down here again we can see this is a strong correlation because our R value is close to a positive 1. So this is going to be a good fit, a strong positive correlation. Now, this notation right here, this E right here, that's your calculator scientific notation for times 10. So this would be 2.2072022133 times 10 to the 10. So basically that means move your decimal 10 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'd have to add a 0 for that last place. Okay, so this is going to be my A value, and then that great big number that we just mentioned is going to be our B value, and that would be our equation. All right, so then the next thing that they ask us to do is use that model to estimate the risk associated with a blood alcohol content of 0.16. Okay, so once I have my equation, basically I'm just plugging 0.16 into it, because I told my calculator to, when it created the equation, to automatically load it in y equals for me. There it is. That's that A times B value that we just got, right? And so if I were to graph that, you can see it's a really good fit for that information that we had. So I could manually go put 16 in the place of X and come up with that value by hand. But there is also a way that I can get my calculator to do it. So this is entirely optional. It's just a little bit of a time saver. So I'm going to do second trace. And this very first button right here, value, I'm just going to hit enter since I'm already highlighting number 1 there for value. And then I can type in any value for X I want, and my calculator will plug it in for me. So they wanted us to try a blood alcohol content of 0.16. So I'm going to do 0.16 and hit enter, and it plugs it in for me and finds that Y value. Now, would this have been interpolation or extrapolation? Interpolation is when they ask me to find a value that is inside the set of data I already have. Extrapolation is when it's outside that set of data. So if you go back and you look at the list of data that we were using on the second page of your notes, our blood alcohol content went up to 0.21 and went down to 0. So 0.16 they were asking me to find is in between those two numbers. So that would be interpolation. If they had asked me to find something that was larger than the highest value, like maybe they asked me to find a blood alcohol content of 0.22, that would be extrapolation. So from that, we can conclude that if a 160-pound person drives after having 6 drinks, they're about 26.35 times more likely to crash than if they were driving while sober. I know that was a lot of steps, so I have it all here in your notes for you so that you can reference back to it whenever you need to. So remember, we went to statistics and then edit, and we put our information in list 1 and list 2. Then we did our stat plot by going to second y equals, turning our plot on, choosing what we wanted and our list that we wanted. We let our calculator set the window for us by doing a zoom 9. And then we got our graph that we could see was exponential, so we would do an exponential regression. So we went back to statistics and went to calculate, chose exponential regression, put in our information, and it gave us our equation.